Okay, good evening everyone. Rich and I just flipped a coin. I'm going first. Now apparently we're not trusted to stay within 20 seconds, so I've been given the clicker. So
Carry on.
but we'll be good. So we'll move straight on. So Richard and I have done a bit together. We've done quite a lot of science together, and we want to tell you about what we've learned. I'm going to talk about the climate and how it's warming and changing and how the Antarctic ice sheet is melting. Richard will then get up and tell you what that means for sea level rise and what will happen. And it's not all doom and gloom. So, I mean, there are some serious things, but there is still much we can do about it. So there it is, carbon dioxide for the last 10,000 years, and that greenhouse gas has been relatively stable until we started burning coal, oil and gas to power our economies, and we are now at a level we have not seen for 3 million years. And 3 million years ago, the world was 2 to 3 degrees warmer and sea level was about 20 metres higher. That's the end game. Simple as that. Okay, so the world is warming, and the world is warming because of us. 2020 was the warmest year. It is second equal with 2016, and you can see that spectacular, unprecedented rise in temperature. Only 1.2 degrees of warming so far. And this target, of course, Paris, we want to keep the climate below 2 degrees. Why? Well, one of the big reasons is there's this big ice block sitting on the southern continent, and if it all melted, 60 metres of sea level rise, as we've already heard tonight, it's not going to do that overnight, but the bit on the left there, the West Antarctic ice sheet, is starting to melt. And it's starting to melt fast, and it's contributing to sea level rise, and Richard will talk about that. Natalie mentioned this. If we hadn't had our friend the ocean there, we would be on a planet that was 36 degrees warmer, 50 degrees Celsius. The ocean has taken up a heck of a lot of the heat. That's why we've only seen 1 degree of global warming. But that heat is in the ocean, and you will notice the Antarctic ice cube sits surrounded by a southern ocean which is taking up most of that heat. So, sea level's rising, the ice is melting, the ocean is heating up, and of course when you heat water it expands. Sea level has risen 20 centimetres since we've been using the oil, the gas and the coal and putting those greenhouse gases in the atmosphere. Now the future's deeply uncertain. We can put in the bank we're going to get 30 centimetres of sea level rise by 2060, so we've got that built in, but what we do depends on us and a bit about what happens with the Antarctic ice sheet. 50 centimetres even if we achieve the Paris target, a metre or more if we don't. Now it's tricky because the scientists are still arguing about what the Antarctic ice sheet's going to do. It's very hard to predict, it's very hard to model because it's mostly underwater. And when that warm ocean gets into the soft underbelly of the ice sheet, things can move very quickly and very fast. So at the moment, we're telling decision makers at the end of the century, worst case scenario, plan for 80 centimetres or plan for 180 centimetres. So there's work to be done. This is a challenge. Richard will touch on that more. Another thing we know about the Antarctic ice sheet, 2 degrees of global warming is curtains for Antarctica and Greenland, and will ultimately result in 20 to 30 metres of sea level rise, which we know happened because it happened 3 million years ago. We already know that. So there's a good news story here. We can still make 2 degrees. We can prevent, potentially, the meltdown of the Antarctic ice sheet and the Greenland ice sheet. That number's not solid. We're working on it. We can make a difference, and I'm the sort of doom guy. Richard's going to lift your spirits when he comes up here. But there's a lot to feel happy about. The world is getting this problem. The world is dealing with this problem. We're leading the way. It can be done. If we don't stop at 2 degrees, we'll stop close. So I think we always have to give our young people that message of hope. And that's me, I think. Richard? Oh, yeah. That's just a change of the slide.
Awesome. Thanks, Tim. Right. Whoa. That was less than 20 seconds, Pat. So Tim's introduced the work we've been doing in Antarctica, trying to understand what the ice sheets do. So what we're trying to do is again, take that understanding of what's happening down in Antarctica and bring it back to Aotearoa. Sea level rise does not rise uniformly, like you imagine when you turn on the bathtub, turn the tap on, and the water level rises uniformly around the bathtub, and you get that little scum mark if you don't clean your bathtub over time. Around the world, that doesn't happen. It's not a uniform rise. How much sea level goes up at Henderson's Bay into Taipari, into Taitokoro, in Northland, is going to be slightly different than what it will be in Bluff. So we're trying to work out how this will be different. As Tim mentioned, sea level rise around the world has gone up by about 18 centimetres since for the last 120 years. That 20 centimetres makes a big difference. We can already see in places like Eastbourne, New Zealand, some of the storms are more frequently crashing over the infrastructure. 20 centimetres makes a difference. But again, in Aotearoa, New Zealand, the sea level rise is actually higher than the global mean. So how will this evolve in the future? And the reason sea level rise is different is because there are lots of different processes going on that affect the amount of sea level expansion. Tim mentioned thermal expansion. Natalie talked about the oceans warming, and in fact, this is what has been happening. And as you warm up water, you can do little experiments at home. If you warm up water in a beaker, the molecules in the beaker will start to move faster, and the water will actually expand, and that's what happens around the world. Areas where the ocean's warming up more, sea level's rising more. Gravity and mass on Earth matters. Right now we have a big ice sheet in Antarctica. As that ice sheet sits there, it actually pulls sea water towards the ice sheet. And so sea level is actually higher next to the ice sheet than further away. As that ice sheet melts, sea level will drop right next to the ice sheet and rise more further away. So the Pacific Islands, for example, sea level will be more than what you'll see next to the Antarctic ice sheet because of the effect of gravitation. The way our atmosphere circles around the Earth and the way the oceans circulate also affect sea level. Here's a couple of cartoons showing how the changes in the wind strength can affect sea level in the tropical Pacific in particular. When you have stronger easterly winds, the ocean actually gets pushed towards the western Pacific and causes the sea level to be higher. As those winds weaken, whether it's through processes like El Niño Southern Oscillation, sea level will actually fall. So those natural climate variability affects sea level as well. This is a map showing the current rate of sea level rise with all of those climatic factors wrapped into one. And the different colors show the rate of sea level rise. The blues are actually areas where sea level is falling. So sea level is actually dropping in this area here. The reds are areas where sea level is rising at a much greater rate. And you can see those red spots right off the coast of Japan where sea level rates are up to 10 millimeters per year increase. Now these will vary as those natural climate features change, but overall that pattern we would expect to see continue into the future. Now those are all climatic factors that affect sea level and the distribution of sea level across the world, but there are also non-climatic factors that we need to be concerned about, particularly here in New Zealand where we live on a plate boundary, as most of us here in this room know. And that the subduction of these tectonic plates causes the land to go up and down. Even as we speak, the land is sinking in some parts around New Zealand and going up in others. And this is actually a map showing, using satellite data, showing the pattern of ups and downs around the lower part of the North Island, blues being areas where it's subsiding up to 5 millimeters, and the greens around zeros. We actually have other areas around New Zealand's coastline where the land is going up. Where land goes up, relative sea level rise is less. Where land's subsiding, sea level rise is greater. This is really where the rubber meets the road. This is a projection from Wellington Harbour, where the blue diamonds are showing you the expected rate of sea level rise if you just take that sort of global average without worrying about the tectonic effects. If you add in the vertical land motion, the fact that Wellington Harbour is subsiding, the amount of sea level rise by 2150 is potentially up to 50 centimetres higher because of that vertical land motion. So you've got to factor all of these different components into producing these sea level projections when you plan for the future. And this just highlights the reason why it's important to put all of these things together. The chart on your right shows some work done by the Parliamentary Commissioner for the Environment, where they were able to show that a 1 in 100 year flood, so a flood event that happens once every 100 years probability, will happen every year in Wellington Harbour, the same amount of flooding with 30 centimetres of sea level rise. If you add in the vertical land movement, what happens is your planning comes forward by about 20 years. So if you're planning for that once-in-a-year event happening in 2070, with vertical land movement, it will actually happen closer to 2050. So from a planning point of view, an infrastructure point of view, it's important. Now, Tim mentioned I was going to be all positive, and I don't know that I have been really, so I apologise. But, you know, we're trying to figure this stuff out so that we can better plan, so that we can better adapt, so that we can adjust to the change that we know is coming. The reality is change is coming. One of the things we're working on right now is, again, to reduce the uncertainty in our ice sheet projections. And that the biggest uncertainty still sits around what those ice sheets will do. We need to reduce that uncertainty to help plan for the future. The Climate Change Commission has come out with a report recently giving us a whole bunch of things that we can do as Kiwis to try to mitigate our emissions. Electric cars, just one example. We're already doing it. That's a photograph of Hugo in Christchurch. At the same time, using the information we're generating to figure out ways to adapt, pathways to the future, advising people perhaps not to build their houses so close to the sea, understanding what will happen with sea level rise and erosion so that we can avoid doing silly things. So again, the scientific knowledge we're generating, bringing it back to New Zealand, helping us to mitigate and adapt. And I think that's the power of science integrated with values, integrated with policy. So thanks very much.